Now, Brian, when we switched it into smart grid mode after the Hallelujah music, I noticed that some wind and solar energy came online. Now, I understand there's a connection between the smart grid and renewables. Can you explain to everyone that connection?
Yeah, that's exactly right. You can think of smart grid as critical technology and infrastructure that we need to bring more renewable energy on the grid and manage a lot more renewable energy. And in fact, the national goal in the US is by 2035 to have 80% of our energy coming from clean sources. And so the smart grid technology is going to be critical for that. And actually, to tell us more about this, I'd like to actually invite to this stage a critical person in this, Dr. Bill Kramer, who's R&D manager at the National Renewable Energy Lab. Bill?
Hey, Brian.
Great to have you here.
Welcome, Bill.
Hey, welcome, buddy.
So Bill, tell me a little bit about NREL and how you work with industry to bring technologies from lab to market.
The National Renewable Energy Laboratory is a Department of Energy laboratory, and we're focused on renewable energy and energy efficiency technologies. We typically focus on research that's 5 years or ahead of industry. We certainly enjoy working with the green companies like the National Instruments to actually take our products from the lab into the marketplace. Jobs in energy are really rapidly increasing across the United States and abroad.
And we see renewable energy as a big market opportunity as well, and it has a chance to create a lot of jobs. If you look at the price of renewables over time, they come down steadily with production. So the more renewables we have, the cheaper they are. And eventually they're going to cross the price point for fossil fuels. We call that the critical cost crossover. And obviously there's a lot of innovation that needs to happen to make that occur sooner. Can you talk about some of the design challenges, Bill, that engineers face in getting us to this crossover?
Absolutely. One of the areas that I've been focused on for the last 20 years is trying to find ways to develop products, as you show up in that test cell location, from prototypes. And it's been a challenge as I've gone through my career and have gone through all the different types of software and hardware that's been developed. One of the key parts of our programs is that we need better prototyping software and hardware so that we can move over into the product development chain much quicker.
That's right. And Ben, I know we've been working with Bill's engineers at NREL on rapid prototyping and HIL. Can you explain?
Yeah, actually the benchmark that I showed earlier was a control algorithm sent to me by one of Bill's engineers at NREL using the MathWorks Simulinx toolchain. And so what we've done is we've run that control algorithm on the x86 CompactRIO, and we've been able to achieve high enough loop rates that we can actually run the control algorithm in real time, but also at the same time be able to play back data in slow motion and debug and see what's happening inside of the control algorithm.
Okay, so you're prototyping a power inverter. For those of us that haven't been in a power engineering course in a few years, remind everyone what a power inverter is and why it's important.
Yeah, you can see on the screen a schematic that's actually moving of a power inverter. What that's doing is it's taking DC power from a source like a battery or a solar array and turning that into AC power, in this case to go back onto the grid. Essentially what it's made up of is an array of switches that are high power, and we call them IGBTs in this situation. The IGBTs are individually controlled to produce the AC power waveforms that are then synchronized back to the grid.
Now, I noticed that this is the system that's actually running. This is the prototype inverter. But I noticed it's not connected to the grid. It's connected to a PXI chassis. So that's simulating the grid, right?
Yeah, I'm happy to show you guys today one of the fastest HIL simulators of an inverter on the market. It's able to read the inputs, calculate the simulation, and update the outputs at over 3 million times per second. And we're able to achieve those incredibly high loop rates by moving all of the calculations of the simulation down into the FPGA.
That's cool.
That is extremely important for both industry and government. I'm really impressed with what you guys have been working on here today. You know, in the past, it was very difficult for us to simulate high-speed power switching in real time. And hardware in the loop for us at NREL in our development of our power electronics and renewable energy technology is extremely important. Being able to actually take and develop control systems and then actually simulate the power electronics in real time is extremely important to us, because what it allows us to do is develop our control algorithms, test them on off conditions without actually blowing up our expensive prototype hardware. So really impressed.
And Bill, we're really excited to be working with NREL to advanced graphical system design for the design of these kind of critical renewable energy and smart grid applications. It looks like we're making some good progress there, but there is one key piece of the puzzle we haven't really addressed yet, and that's the deployment of these inverter control systems. Can you tell everybody what we're working on there?
Absolutely. I'm pleased to announce today that we'll be working with NI to develop a advanced controller using FPGA and I/O technologies so that we can actually use this in our modular power electronics program that we're working with California Energy Commission. So our objective is to develop low-cost inverters which are high speed, will take us all the way from prototype to product.
Yeah, we're really excited. And actually, that's a great lead-in to the announcement of the next generation single board RIO that we're releasing today. And this is designed with a Spartan 6 FPGA, 400 megahertz PowerPC processor. And what's really exciting about this is on the backside, there's this RIO mezzanine connector, or RMC. And this is designed to make this the most customization-friendly single board RIO target to date, not to mention the smallest and lowest cost. And actually, this is what we're working on with NREL, is to develop this interface to your board there. And Bill, I'll hand that to you.
Thank you.
To create very application-specific embedded systems for things like inverter control and this modular power electronics concept.
Very excited.
Okay, Bill, we look forward to yeah. Cool. So, Bill, thanks again. We look forward to continuing to work with your engineers on these next generation smart grid technologies. Appreciate you being here at NI Week. And thank you, Brian, Ben.